Well, you know.
Section 3.3, solving equations with the variables on both sides of the equation. Now this is going to go an extra step beyond what we did in section 3.2. In fact, I went ahead and wrote out the steps for you. These are steps that you should try to memorize. My suggestion is that you write them down and read through them a few times to keep them fresh in your head so that you remember as you encounter these problems throughout the entire course. All right, now step 1 is the step from the last section. Simplify both sides of the equation by eliminating parentheses, that's the distributive property, and combining like terms. Sometimes you have to do this, sometimes the sides are already simplified. But here's the new one. Get the variable on only one side of the equation. You can't isolate the variable if it's on both sides of the equation. So I'm going to show you what to do as far as getting the variable on one side. And because these problems are going to have the variable on both sides, as you can see with the first couple of examples that I have here, there are a couple of special cases that we'll have to consider also. But once the variable is on one side of the equation, then it becomes like a two-step equation that you had back in section 1. You're going to do any adding or subtracting, then you're going to do any multiplying or dividing. So there's these 4 key steps here, although step 1 could have as many as a couple different things to keep track of. Now again, not every equation is going to require all 4 steps. In fact, the very first example here, there is no simplifying to do. The left side of the equation, 6x plus 5, doesn't have any parentheses nor like terms, and the right side of the equation, 4x minus 9, doesn't have any parentheses or like terms. But I have to do step 2 because the variable's on both sides of the equation. I have 6x on the left, I have 4x on the right. I either have to get rid of the 6x or I have to get rid of the 4x. And I usually take the one with the smaller coefficient. This has a coefficient of 6, this has a coefficient of 4. I'm going to get rid of this 4x that's on this side, 4x minus 9, the right side of the equation. To get rid of a positive 4x, I'm going to subtract 4x. Now, if I'm using the subtraction property of equality and I subtract 4x on the right, I got to subtract 4x on the left. So watch what I'm going to do. I'm going to put it right underneath this term because that way my like terms are lined up. I have 6x and a minus 4x, which is like a negative 4x. That's a positive 2x. And then I have the plus 5. Nothing combines with that. These are going to add up to 0, and that's going to leave minus 9, which is negative 9. That's a two-step equation that we had a couple of sections ago. I'm going to solve this now by undoing any adding or subtracting. So I'll get rid of the plus 5 by subtracting 5 from both sides. And I get 2x is equal to a negative 9 and a negative 5 is a negative 14. Then I'm going to get rid of the 2 that's times the x to isolate the variable. I'm going to divide both sides by 2. I write it as a separate step here. Those cancel out as a factor 1, and I get x equals negative 14 divided by a positive 2 is a negative 7. And that's my answer. Now we can still check our work because any equation that we have been solving in this chapter up to this point, you can check your work. If you take negative 7, substitute it back in for the variable, but you'd have to substitute it in here and in here. 6 times negative 7, negative 42, plus 5 is negative 37. 4 times negative 7 is negative 28. Negative 28 minus 9 is negative 37. See, it will work out. I will get a true statement. All right, so that would be a good way to check it. You could write it down on paper or do a little mental math like I did. Now, the next example, I am going to have to do step 1 on the left side of the equation because I have parentheses. I'm going to distribute. That's 2x minus 6. 2 times 3 minus 6. And then I have minus 9. The 2 is not times the 9. It's not in the parentheses. So I have an extra step. I have to combine like terms. That's right here and right here. Now these minus signs, think of them as negatives. Negative 6, negative 9, a negative 6 plus a negative 9 is a negative 15. So I'm going to write 2x minus 15 equals 4x plus 7. Now the problem looks a little bit like the first example that I did. I have the variable on both sides. There are no longer any parentheses or like terms. I have 2x on the left, 4x on the right. As I mentioned before, I prefer to get rid of the one with the smaller coefficient. So in this case, I'm going to get rid of the positive 2x. I am going to subtract 2x from both sides. Now here I did the shortcut by putting it underneath the little minuses and such. Here I'm going to work it out the more traditional way. I'm going to subtract 2x from both sides. 2x and this minus 2x, those are going to cancel out. I'm going to get a minus or a negative 15. And then on the right side, I have like terms. A positive 4x and this minus or negative 2x is going to give me a positive 2x, and then don't forget the plus 7. Now my variable's on the right. That's okay. I can deal with that. I've got to get rid of the 2 and the 7. I'm going to undo the plus 7 first because we undo adding and subtracting before multiplying and dividing. So I'm going to get rid of this plus 7 by subtracting 7 from both sides. Negative 15 minus 7, it's the same as negative 15 plus a negative 7. That's negative 22. You can see how important it is for you to know your arithmetic for sign numbers. And then these are going to cancel out as add up to 0, and that's going to give me 2x. Almost done. One more step to go. Divide both sides by 2. And negative divided by positive is negative. It goes in 11 times. Factor of 1, I get x equals negative 11, or if you want to think of it as negative 11 equals x. All right, now what we'll do is we'll apply this equations with the variable on both sides to a story problem here. Look at the example I have. It says, write the verbal sentence as an equation, then solve. 4 less than negative 7 times the number is equal to 18 minus 6 times the number. Well, that's a little confusing. I'm going to have to read that one again, but I know what I'm looking for here is the number, so I'm going to let x equal the number. That's my unknown. So let me go back and read this. 4 less than means to subtract, and that's the one that changes the order around. Minus 7 times the number is equal to, that means, of course, equality, 18 minus, there's another subtraction, but that doesn't change the order around, and there's another multiplication. 4 less than, that means I'm subtracting 4 from negative 7 times this number over here, times x, so negative 7x, is equal to 18 minus, 18, as you read it, you write it, 18 minus 6 times the number, 6 times x. Well, there's my variable on both sides. I don't have to simplify either side because there are no parentheses, there are no like terms. I have a negative 7x on the left, I have a minus or a negative 6x on the right. This has the smaller coefficient, I'm going to get rid of this. To get rid of a negative 7x, I'm going to add 7x. I'm just going to use a little shortcut here, notation. And these are going to cancel out. That minus 4 is a negative 4, and I have an 18. Now, be careful. Minus 6x plus 7x. A negative 6 and a positive 7 is a positive 1. So I'm going to write plus 1x or just plus x. Remember, x means the same as 1x. Well, my variable is very close to being by itself. I have to get rid of this 18. So again, I'll use the shortcut notation. I'll subtract 18 from both sides. A negative 4 and a negative 18 is a negative 22. And that's x. And that's my guide. Now, it is a story problem, so I'm going to go ahead and do the last step. I'm going to write it out formally. I'm going to write the number is negative 22. Okay? Next problem up. We have a diagram of a square. We have the sides measured. It says find the value of x for the given square. Now, I had underlined square here because I want to make sure you understand with a square, all 4 sides have the same length. This is not a perimeter problem like we've done in the past. I have to use the fact that the 2 sides are going to have the same measure. The sides are said to be congruent. They have the same measure. So that means this measurement and this measurement are equal. So I'm going to write 8x minus 5 is equal to 3x plus 20. I set the 2 measures of the sides equal to one another since it's a square. Now it's like the last example. I've got to get the variable on one side. There is no simplifying to worry about. I'm going to subtract the 3x from both sides. Again, I'm using a little shortcut notation. 5x minus 5 is equal to, looks like 20. Almost done. Get rid of the minus 5 by adding 5 to both sides. I have 5x equals 25. Divide by 5. Both sides. 5's cancel just like we planned. 25 divided by 5 is 5. So I have x is equal to 5. All right. All right, I have 2 more examples that I want to go over, and we're going to go over these quickly. These are special cases. These special cases come into these equations rather than the others that we've had in previous sections because these are our first equations that have the variable on both sides. When the variable's on both sides and you attempt to get rid of it on one side, sometimes it drops out of both sides, and you would be either left with a true statement or a false statement. I have an example of each. Let's start off with this one. If I get rid of the parentheses by distributing, I have 14x plus 21 equals 21 plus 14x. See, I have the same amount of the variable on both sides. So if I subtract 14x from both sides, the variable not only drops out on the right here, it drops out on the left. And look at what I'm left with. I'm left with the statement 21 equals 21, which is obviously a true statement. This is what we call an identity. This means that no matter what number we substitute in for our variable x here, it's going to be true. So when this occurs, I want you to write down for your answers I want you to write down all real numbers. Because that means for any number that I plug in for x, I will get a true statement. Don't just write down identity. That's just what happens to be called. I want you to write down all real numbers. Now, if you don't like writing down all the three of those words here, you can do it the way I was taught when I was in school, which is to use set notation, the set of all x, such that x is an element of the set of real numbers. I think you'll like this a lot better. On the right side, though, is another equation, another special case. This has parentheses also. I'm going to distribute. I get negative 8 plus 4 times 3, 12x is equal to 12x. And you can probably see it coming that the variable is on both sides, but they have the same amount. They both have 12x. So if I subtract 12x from both sides, it cancels out here, it leaves negative 8, and over here it cancels out and leaves 0. Well, with the first example, it left me a true statement. Here, this is clearly false. This is what we call a contradiction. Contradiction. So if this occurs, don't type in the word contradiction. That's just what this is called. It means there isn't an answer. There are no answers that will work for here. So you just type in no solution, and that'll be fine. No solution will be fine. Now there's a symbol, a set symbol that represents that, in this case, no solution, and that's the empty set symbol, which you may have seen before. It looks like a 0 with a slash through it. Be aware of these two special cases. Make sure you practice these problems so that you know how to solve equations that have the variable on both sides. Always, always, always practice, practice, practice.